Welcome to my class. I'm Drew Collop. In today's class, we're going to learn about solving of equations. When solving an equation, we have an unknown. The unknown is a variable. The goal is to isolate that variable on one side of the equation and everything else on the other side. Once we have that variable isolated on one side, whatever is on the other side of the equation is what that variable is equal to. Please note, when you have equations with fractions, please find the lowest common denominator and multiply both sides by that. This will simplify the equation and make it much easier to work with. Oftentimes, our unknown is x. We want to move all the x's to one side and have only one x there. And then whatever's on the other side is what x is equal to. This is called algebra, but really what we're doing is just rearranging the equation. This skill of rearranging an equation is very important that you fully have this mastered. Let's look at example 1 together. In example 1, you can see I have an unknown. The unknown is a variable. It's the variable x. We don't know what that is. This is an equation because it's two expressions and they're equal to each other. There's only one unknown, therefore I can solve this. Let's work this out now. The rules of Bedmus apply to solving equations as well. First things first, we have brackets here. I'd like to combine those together, 2x minus 1, but I cannot because they are not like terms. So to get rid of the brackets, I will distribute the 2 to both terms inside the brackets. Please don't write an equal sign there. We already have an equal sign. Only one is required. Now you can see we've got rid of the brackets. Now what we want to do is we want to move all the values of x on one side and all the other values on the other side. Just going to move this 5 over a little bit. So first things first, let's put all the x's on the left side and all the numbers on the right side. So maybe you've learned that, well, we move the 5 over to the other side and it becomes negative, and then that's gone. Why does that work? Let's examine that. Earlier, I talked about solving an equation like a balancing act. Whatever you do to one side of the equation, if I add more to this side, I have to add more to that side. If I take away from this side, I got to take away from that side. If I multiply one side, I got to multiply by the other side. As long as you do the same thing to both sides, you don't change the equation. You just change how the equation is represented. So let's try that now. Now I want to get rid of the 5. It's positive 5. So to get rid of it, I just subtract 5. No big deal. But to make sure it stays in balance, I must subtract both sides by 5. In doing so, the 5's cancel out on this side. This gives me 3x equals 4x. We'll combine these together. 2 minus 5 is minus 7. Here we want to move the 4x to the other side. It's a positive 4x, so I do the opposite. I subtract 4x. If I do it to one side, I have to do the same thing to the other side. Now these are like terms. 3x minus 4x is minus 1x, and that's equal to, you can see these cancel each other out, and that's equal to minus 7. So here I have minus 1, x is equal to minus 7. But I want to solve for x, so I need to isolate x on its own. This value of minus 1, this is the coefficient in front of x. So to get rid of that, remember coefficient, we're multiplying x by that value, so I do the opposite. I divide it by minus 1. To make sure it's in balance, I must divide the other side by minus 1. These cancel out. Here I get x being equal to, what's minus 7 divided by minus 1? Two negatives make it positive. Answer is 7. X is equal to 7. Final answer. This skill of rearranging equations is pivotal that you have this mastered. Now the question is how do you know that x is equal to 7? Well, the wonderful thing about solving equations, we can always do a check. So let's show you how we do that. Let's check it. What we do is we go back to the original equation. Don't use something that's already been modified. Go back and take the original equation. We take the left side, which was what? It was 3x plus 5, and we take the right side, which was 2x minus 1. Notice I've gone back to the original problem, the one that's typed out, not one I've modified at all. Very important. What I then do, I substitute in what x is equal to. So I'm going to sub in x is equal to 7. Substitution means I'm going to remove any place there's an x and put in its place the 7. So I have an x here, and I have an x here. So let's substitute that in. 3 times 7 plus 5 on one side. These are separate. Don't combine them. I have 2 times 7 minus 1. What I do now is I collect like terms and get a number on both sides. If I have the same number on the left side as I do on the right side, left side equals right side, then I know that x is truly equal to 7. Let's try that now. 3 times 7 is 21. 21 plus 5, and I get 26 right here. Over here, I have 2. 2 times 7 is 14 minus 1. After that, 2 times 14 minus 1 is 13. 13 times 2, 26. Left side equals right side. Therefore, we know that x is truly equal to 7. So please note, you can do this for any problem you work with. You can always double check it. I advise you to do that during assessments if you have extra time. The key thing is, make sure you're plugging it back in to the original problem. If you messed up some of the math going from this step to this step and you use this one as your check, then chances are you will get left side equal to right side. That's why you always want to go back to the original problem. Let's try the next one. The next one has a fraction. What did I say at the beginning of today's class? I said if you have a fractional equation, find the lowest common denominator and multiply both sides by that. So what's the lowest common denominator here? Well, let's turn these all into fractions. You can see the lowest common denominator between these terms is 5. So what I'm going to do is I'm going to take my equation. I'm going to multiply both sides by 5. Very important we put brackets around the original equation, because that 5 has to be multiplied by every term in there. Let's combine these together. You can see here we have 5 on the bottom and 5 on the top, so these just cancel each other out. 5 divided by 5 is 1. This gives me 4x is equal to, over here now, distribute the 5 to both terms. 10x minus 20. Notice, I didn't change anything. These two equations are exactly the same. One is much easier to work with. Let's move the 10x to the other side. Minus 10x minus 10x. We have 10x minus 10x equals 0x. We combine these together. 4 minus 10 minus 6x equals minus 20. Our coefficient on the x is minus 6. We divide both sides by minus 6, and they cancel each other out. Finally here, x is equal to, two negatives make a positive, 20 over 6. However, is this in simplest terms? It is not. I can take a 2 out of the top, and I can take a 2 out of the bottom. This gives me 10 over 3. Final answer. When you have an equation you have to solve, and there's fractions in the equation, find the lowest common denominator of all terms, both left side and right side, in your equation, and multiply both sides by that lowest common denominator. When you do that, the fractions will no longer exist. Let's do a check on that now. So left side was 4x over 5, and right side was 2x minus 4. Remember, I'm going back to the original equation. Wherever there's an x, we're going to substitute in 10 divided by 3. What do we get now? We have 4, 10 over 3 divided by 5. And over here we get 2, 10 over 3 minus 4. Here we have 4 times 10 over 3. When I multiply fractions, either turn the 4 into a fraction, 4 over 1, multiply the numerators, multiply the denominators. 4 times 10 is 40 over 3. I'm dividing by 5, which means the same thing as multiplying by 1/5. Here I can simplify this down a bit. I can take a 5 out of here, and I can take a 5 out of here. How many times does 5 go into 40? It goes in 8 times. So here I get this side 8 over 3. Let's see what happens on the other side now. Do the same thing. 20 over 3 minus 4. I got to find a common denominator. 20 over 3 minus, this is 4 over 1. Lowest common denominator would be 3. This is 12 over 3. And when I solve that, I get 8 over 3. Left side equals right side. Therefore, I can be pretty sure that my correct answer is 10 over 3. So as a reminder here, find the lowest common denominator of all the terms, both left side and right side. Multiply both sides, every term, by that lowest common denominator. The fractions will be gone. Move all your x's to one side and everything else to the other side. And when you have x isolated on its own, 1x isolated on its own, you will know what x is equal to, your unknown. Let's pool together our knowledge from earlier lectures where we distributed values outside the brackets, or we did FOIL with a binomial multiplied by another binomial. We are going to distribute here and here, here and here. We get x squared minus 3x plus 15x minus 45. Next up, we'll distribute the negative sign to all terms in here. It says negative, it means negative 1, minus x squared plus 6x minus 9. I'm just switching the sign to the opposite sign. Equal sign comes in here. 30 minus, the minus 15 gets distributed to all terms inside, minus 15x plus 15. Notice there's only one equal sign. Do not place an equal sign there. We already have one, that's all we need. Now let's see if we can collect like terms on each side. Here I have x squared, x squared. X squared minus x squared is 0. X squared. So those just cancel each other out. Don't have to write anything down on the next line. I have x, x, and an x. Minus 3x plus 15x is 12x plus 6 is 18x. We've moved those down. Finally here, we have two constants, minus 45, minus 9. We bring those down, we get minus 54. We can cross those off. Moving to the other side of the equation, we have two constants here. 30 plus 15 is 45. And lastly, we just have a single x there, minus 15x. Cross it off. Much more manageable. Let's isolate x on its own by adding 54 to both sides. So we're adding 54 to that side. Whatever we do to one side, we have to do the same thing to the other side. In doing that, minus 54 plus 54 equals 0. Those are gone. 18x is equal to, in this case here, we'll collect like terms. 45 plus 54, we get 99. Minus 15x. Finally, let's get rid of the minus 15x by adding 15x to this side. Whatever I do to one side, have to do the same thing to the other side of the equation. These cancel each other out. Collect like terms. 18 plus 15, 33x is equal to 99. Now we have 33 as a coefficient in front of x. 33 times x, I do the opposite. I divide both sides by 33. In doing so, the 33's cancel each other out, and we have x here is equal to 99 divided by 33 is going to be 3. If you wanted to, you could double check by subbing this value into the left side and right side of the equation. I would advise you try that on your own to see if you get the same answer. If you sub it into both sides, you should get both sides being equal to 0. 0 is equal to 0. That is correct. Therefore, left side equals right side. Using the knowledge we've gained so far, I'd like you to attempt this on your own. For this equation, remember what you do at the beginning when you have fractions in there. Give that a try now. Then we'll take it up. The answer you should have obtained is x is equal to 24 divided by 35. Let's take it up. Let's find the lowest common denominator between 2, 3, and 5. Break it down into its prime numbers. 2, 3, and 5. Each are prime numbers. 2 times 3 times 5, and that is equal to 30. Lowest common denominator between 2, 3, and 5 is 30. So what I do is I multiply both sides of the equation. Every single term has to be multiplied by 30. Whatever I do to one side of the equation, as long as I do it to both sides, it doesn't change the equation at all. Make sure you distribute this here and here. What do we get now? I'm multiplying 30 by 2x over 3. I am then multiplying 30 again by x over 2. And then I'm multiplying 30 by 4 over 5. When we're multiplying whole numbers and fractions, we can turn those whole numbers into fractions by placing them over a denominator of 1. Let's cancel some terms out here. I can simplify the first grouping here. Take a 3 out, 1 and 10. Second grouping here, I can take a 2 out, 1 and 15. And finally here, I can take a 5 out, 1 and 6. In doing so, I get 20x plus 15x is equal to 24. These are exactly the same equation. One of them is a heck of a lot easier to work with, though. So let's collect like terms right here. 35x is equal to 24. Isolate x on its own by dividing both sides by 35. 35 cancels out. And I'm left with x being equal to 24 over 35. Final answer. Again, if you wanted to, you can sub these into your original equation. And you can see this side here is already 4 over 5. So if you sub in 24 over 35 into the left side, you should get that being equal to 4 over 5. You can try that on your own. Here's something a bit different. In this case here, we can still solve for x. However, our final answer will not be just a number. Notice there's an a and a b variable in there. But we can still do the same properties to solve for this. What do we do when we have a fraction in an equation? We find the lowest common denominator and we multiply both sides by that. Lowest common denominator here is going to be 2. So I multiply both sides by 2. Or if you have a problem understanding that, just make sure you multiply every single term. Remember, terms are separated by addition and subtraction signs. Multiply every single term by 2. And doing this, 2 times x a plus 3 over 2 is equal to 2 times 2b minus 2 times 1. We can simplify these down. 2 and 2 comes out, 1 and 1. We have x a plus 3 is equal to 2 times 2b, 4b. 1 minus 2 times 1 is minus 2. Now you can see by doing that, once again, we've eliminated all the fractions in this equation. What you could do next is you could distribute the x to this value and this value here. But I'm not going to do that. Let me show you why. I want to isolate x on its own. I have x times a plus 3. So to get rid of that, I'm going to divide both sides by a plus 3. These cancel each other out. I'm left with x is equal to 4b minus 2 divided by a plus 3. Now we have solved for x. It's not a number, but we still solve for x. This is as far as we can take it. Unless we know the values of a and b, there's nothing else we can do any further. Let's work on example 6 together. Here we have x plus 1 squared is equal to 9. What you could do, you could start this off by saying x plus 1 times x plus 1 equals 9, and then say x squared plus x plus 1 equals 9, and then you do x squared plus 2x plus 1 equals 9. But then it's getting more difficult. So I wouldn't advise you do that. There's a much easier way to go about this. What you can see here, we have this grouping here, x plus 1, we have that squared. What I'm going to do to simplify this is I'm going to take the square root of that. Take the square root of both sides. As long as I do the same thing to both sides, it doesn't change the equation at all. X plus 1, we square it, plus 9. Now remember what happens when we have a fractional exponent. Let's keep that as a square root. Over here, a square root is like having an exponent of 1/2. So I can say squared and then multiply by 1/2 because in this case my root is 1/2. This gives me x plus 1, 2 over 2, which is equal to square root 9. 2 over 2, this is just equal to 1. So this is x plus 1 to the exponent 1 is equal to square root 9. And then we can just remove that 1. If during the course of algebra I have to take the square root of a number, this is when there are two answers. So this becomes x plus 1 is equal to, I take the square root of 9. Square root of 9 is 3. But because I'm doing algebra and I'm doing a square root, I must have both positive and negative 3. Let's move the 1 over to the other side by subtracting 1. These cancel each other out. And I have x is equal to minus 1 plus or minus 3. For this particular equation, there will be two answers. X is equal to minus 1 plus 3, and x is equal to minus 1 minus 3. I get 2 as an answer. I get minus 4 as an answer. Those should both be correct. If we sub them in over here, we sub in 2. 2 plus 1 is 3. 3 squared is 9. Sub in minus 4. Minus 4 plus 1 is minus 3. Minus 3 times minus 3 is positive 9. So you can see both of these satisfy that equation. Later on in the course, we will actually work through this method. And by doing so, we'll get the same answer. However, if you can just take the square root of both sides, that's a much easier method. So for now, this is all we're going to work with, but later on it's going to be more challenging and we'll have to work with this method. Sometimes when you're solving for an equation, your variable can be in more than one term, and they are not like terms, so they cannot be combined. So what do we do in a situation like that? What we do is we group all terms with x on one side and everything else on the other side. We then pull out a common factor of x. At that point, x is multiplied by everything else. So all we do, we divide both sides by what's in the brackets. Let me show you what I mean. Example 7, 3x equals 5 minus 2xy. Let's put all the x's on one side and all of our numbers on the other side. So to move the 2xy to the other side, I have to add 2xy to both sides. These cancel each other out. This then gives me 3x plus 2xy is equal to 5. At this point, I have every term with x on one side, and I have every term without x on the other side. Unfortunately, these are not like terms. One is x and one is xy, so I cannot combine them together. What I can do is factor out the x. Here, I have an x in both of them. If x was outside the brackets, I could distribute it to both these terms. We're doing the opposite of distribution. We are factoring. Let's pull an x out of both of those terms. You can see we've taken the x out If I was to distribute it here and here, I would get to the line above. However, we have now factored it out. To isolate x on its own now, we will divide both sides by everything but the x. Now this whole thing and this whole thing, they're the same, so they cancel each other out. This gives me 5 over 3 plus 2y. Final answer. As you can see, this is a bit different, but with the extra step of factoring, this is quite simple to solve. Here's some practice problems to try on your own. 1, 2, and 3. Pause your video, give these a try. Solving for x. Let's take them up. Let's put all the x's on one side and everything else on the other side. 3x plus 2xy equals 3. We're going to add y to both sides. So we have plus 3y on that side. You can then see we don't have like terms here, but we have a common factor of x. So I can factor out the x. 3 plus 2y equals 3 plus y. Now what I'm going to do, I'm going to divide both sides by everything that's in the brackets beside the x. In doing so, these values cancel out, and I'm left with x is equal to 3 plus y over 3 plus 2y. This is the final answer, but I want you to be careful here. Sometimes students can get what I call canceling crazy. They see this and they say, oh, this is easy. There's a 3 on the top and a 3 on the bottom and a y on the top and the y on the bottom. So in this case, x is equal to 1/2. Wrong. Why is that wrong? Remember, if we're canceling out values, every single term on the top and every single term on the bottom must have that. There's a 3 here and a 3 here, but no 3 and no 3. Over here we have a y and a y, but here no y, no y. As a result, this is as far as we can take it. Remember that. To cancel terms out in a fraction, all terms in the numerator and all terms in the denominator must have that same value. Let's take up 2. Distribute. Distribute here. Now we have a v. And we distribute here. Wx. Let's move all the terms with x on one side and every term without the x on the other side. 3x plus vx. Move my wx to the other side, becomes minus wx. We're going to move my 3 and my v to the other side here. This becomes positive 3, positive v. At this point, we'd like to collect like terms, but unfortunately these are not like terms. But what they are, they do have a common factor of x. So I can take that x value out. And then divide both sides by what's in the brackets. As a result, these cancel each other out, and I get x being equal to w plus 3 plus v over 3 plus v minus w. That is as far as we can take it. Yes, there is a w and a 3 and a v in the top, and yes, there is a v and a 3 and a w on the bottom. However, it's not exactly the same. The w is subtraction. And then if we look at every single term, they are each individual on the top and on the bottom. As a result, this is your final answer. Be careful of that. Make sure you only cancel out where appropriate. Let's take up the next one. Previously, I showed an example where we had some values in brackets squared, it was equal to 9. And what I did is I did the square root of both sides. You could technically do that here, but this is going to be very challenging to work with. So I would advise you not to do that. It's much easier just to expand and distribute. So let's do FOIL on this. X squared plus 2x plus 2x plus 4. X squared plus x minus 3. Collect like terms. Let's put all of our terms with x on one side and all terms without x on the other side. We move the x squared to the other side, becomes minus x squared. Move the x to the other side, becomes minus x. Move the 4 to the other side, becomes minus 4. Look at this. We have x squared minus x squared. 0x squared. So these just cancel each other out. 4 minus x, this is equal to 3x. Minus 3 minus 4, minus 7. I will then divide both sides by 3 to isolate x on its own. And x is equal to minus 7 over 3. Lastly now, let's examine a word problem. Being able to build equations and solve them from word problems is very important for your work in the laboratory. Most work in the lab, it doesn't give you the equation directly. You have to read through the lab, determine what the unknowns are, what the variables are, and collect data and then solve. In this question, we're asking for the surface area. We'll call that SA of a rectangular prism, a box. We know that equation. It's right here. Surface area is 2 times, in brackets, length times width plus height times width times length times height. In this problem, we've been given the surface area. We've also been given the height and the width. What we don't know is the length. That's our unknown. What is our length? You might say, what's the purpose of this? Well, in one of our laboratories, you're actually going to examine plant cells in a microscope, and you're going to have to measure in micrometers the length and the width, and from that, determine the area inside. Let's use that equation. SA equals 2 length times width plus height times width plus length times height. What we could do now is we could substitute in the variables we do know. So we know the surface area, 62 micrometers squared, 2 times length we don't know, times the width, 2.0 micrometers, plus height, which is 8.0 micrometers, times my width, 2.0 micrometers, plus the unknown length, times the height, 8.0 micrometers. We would then solve for L. I would not encourage you to do this. The reason why that is, you're going to have to move around a lot of numbers, and there can be mistakes along the way. So my advice to you is try and rearrange the equation first, solving for that one variable that is unknown. And once you have that solved, then sub in the variables you do know. Let me show you. With this question, we're trying to solve for length. So let's first distribute the 2 to all terms inside. Surface area equals 2 length width plus 2 height width plus 2 length height. Next, I want to place all terms that have length on one side and all the terms without length on the other side. Surface area, this term here does not have length in it. We move it to the other side of the equation by subtracting both sides by 2hw. And we're left with this equation. Here you can see these are not like terms, but they have a common factor of our unknown L. So let's pull that common factor out. Now that I have L on its own, multiplied by what's in the brackets, I divide both sides by what's in the brackets. As long as I do it to both sides of the equation, it is fine. These will then cancel each other out. Here I get length is equal to surface area minus 2hw, 2 width, plus 2 height. Now that I've rearranged it, and I have length isolated on its own, let's now substitute the variables we do know. Surface area, 62 micrometers squared, minus 2. Our height was 8.0 micrometers, multiplied by our width, 2.0 micrometers. all divide that by 2 times the width. The width was 2.0 micrometers plus 2 times the height, which is 8.0 micrometers. Let's work this out now. 62 micrometers squared, subtract. We're going to multiply these values together. 2 times 8 is 16, times 2 is 32. 32. Notice here you don't see an exponent on your unit, but we know it's there. It's a 1. We have 2 exponents with the same base. We're multiplying them together, so we add them. So this gives me micrometers squared. On the bottom here now, 2 times 2 is 4 micrometers, plus 2 times 8 is going to be 16 micrometers. Let's collect like terms. On the top I have like terms. Notice it was important that this became squared. We can only collect these terms together if they are like terms. Micrometers squared and micrometers are not like terms, but micrometers squared and micrometers squared are. We combine those together. 62 minus 32 is 30 micrometers squared. On the bottom here, we have like terms, micrometers and micrometers. 4 plus 16 is 20 micrometers. Let's divide them now. Remember once again, you don't see an exponent there, it's a 1. We can take a 10 out of the top and out of the bottom. This gives me 3 over 2 micrometers squared divided by micrometers to the exponent 1. 2 exponents with the same base. I divide them, I subtract those exponents. This gives me micrometers to the exponent 1. In the end, 3 divided by 5 is 1.5 micrometers. Is that the final answer? These are measured values. Let's look at significant digits. When we multiplied these together, this is an exact number, exactly 2. So there's an infinite number of significant digits there. We have 2 significant digits and 2. We multiply them together, 2 significant digits. On the bottom here, we're multiplying an exact number, so that doesn't change. There's still 2 significant digits. So technically, there would be 4.0, and this one would be 16 to keep 2 significant digits. When we subtract on the top here now, we have to the nearest ones, to the nearest ones, so we round this off to the nearest ones. So the 3 and the 0 are both significant. On the bottom here now, we're adding them. This is to the nearest 10th, and this is to the nearest 1. So this will be rounded off to the nearest ones. So 2 significant digits here. When we divide that out, 2 and 2, so we report both of those digits, 1.5. That is the final answer. So this is approximately equal to 1.5 micrometers. Again, I'm just putting the approximation symbol in to indicate that I have applied the rounding rules to this number. Finally, this is a word problem. So you should write something like, therefore, the length was 1.5 micrometers. A lot of steps along the way to solve this problem. We were given the formula. My opinion on memorizing formulas, it's a complete waste of time. In the old days, you didn't have a cell phone on you connected to the internet at all times. Now you do. When you're in the working world, if you ever need to recall a formula, you can bring it up on your phone. Also, if there's formulas you use all the time, you can put them on a Post-it note and leave them on your workbench. Again, my advice to you is solve for the unknown first before substituting in any values. That way you're not transferring the wrong number from one level to the other, and you don't have to deal with units just yet. Once you have it rearranged and you've solved for the unknown, then substitute in your knowns. When you're collecting like terms, make sure your units are also of like terms. And then finally, round off to the proper number of significant digits and remember to report units. In today's lecture, we've utilized many of the techniques we've learned previously. We've now done that to solve for an unknown by rearranging an equation. The skill of rearranging an equation is very important. You must master that skill. Remember, When you solve an equation, you can always substitute in what your final answer is into the original equation, left side and right side. If you get the same number from the left side as you do for the right side, when you substitute in what you believe to be the final answer, if you get the same numbers on both sides, then you can be certain you are correct. We will do much more solving of equations throughout this course and in future math courses. That's all for today. Until next time.